I want to show you, but we can at least talk those points, and I think you'll get the gist from that. So as you can see, Bob's on the system with this Command DXE running at system level. I'm still logged onto the system here. One of the biggest things is when you get into a system like this and you run it at system level, the problem is I don't have access to the person's logged in network drives. So if the logged in user has a bunch of network drives, you can't get access to them at system level. You just can't do it. So we start looking into, well, how can we? How can we actually become or steal the security rights, the security cookie of the running user? So we went to Microsoft's development network, started doing some research, and we discovered, yes, we can. So we wrote a quick little program called Impersonate. The way Impersonate works, the way we have it written up, IMP, and then all we need is a process ID off any running process owned by the user whose rights we want to steal. So we'll grab process ID 2268. So we run Impersonate with 2268, comes back as successful. Now if we sort on here, we see we have two Command DXEs. We have one running at system and one running as the user. So what we just did was we had our process go in, steal his running token, or his security token off his running process. Since we're at system level, we have access to that. And then we turn around and created a process to run as that user using that security token. The weird thing is we have one window here. In that one window, we actually have two Command DXEs running under two different users. And we found out if I would go ahead and type in a command right now, it would run as system. And the screen would still look like it's the same one, but if I type in another command, it would run as the user's token we stole. So we found out the best way to handle that is exit out of one of them. Now we are DSH. We didn't know his password. We pulled his security token off a running process, and we actually degraded our rights down to the running user. Instantly, if that user had any mapped drives, we just gained access to all of his network resources. If we wanted to, we could actually map new drives as that user to any other systems that he has rights to. Just a couple quick things. Now we got that back up again. Let's go ahead and shut this down just so you can see it. We won't leave it up long, but there. There's a full desktop without even logging on. There's still the log on there. So now if we'd log back in, just so you can see the multiple desktop environment that it does exist, there's that desktop, and if we do Control-Alt-Delete, switches us back to the other desktop. Cancel back to the other desktop. So you can see it's a multiple desktop environment. One, we've gained access by bypassing the WinLogon desktop, we've got access. Now we can also impersonate any running users that are logged onto that system by stealing their security token, grabbing access to any of their network resources. Shut a few of these things down. No. Come on. Get rid of that desktop. Okay. Did that, we did that. Okay, now what kind of questions does this whole demonstration pose? Basic protection. How do you protect my system from these type of exploits? You may be able to do it with group policies, and I say maybe because if you'd seen my presentation at DEF CON 12, it was completely on subverting Windows group policies. So those only work so well. You can remove or disable Utility Manager. If the user knows that's been done, the attacker knows that can be done, he can easily put that back on there with a BART PE disk, so that's not a problem. Big one, disable boot CD-ROM, lock the BIOS, disable booting from a USB devices. That actually would hurt this really quickly. It would slow him down. You'd have to find a whole new methodology. You can run host IDS on a server if you're trying to protect the server, because typically what this thing does, it puts two files on it. It puts the IMP within the System32 directory. It replaces the osk.exe. So typically a good host-based IDS on a server will protect you. Also, this attack works, at least the OSK part, works against remote desktop. So if you put this onto a box, you can go in with remote desktop and get a command prompt up and if you go against the server, you don't have limitations with Explorer. You can bring up the full desktop without running out any resources. So you could basically do this to a server or anything that has remote desktop, remote into this box, Windows U, get a command prompt up, launch Explorer, have a full desktop that you can do anything you want with for a certain period of time. Because you've never actually logged in with remote desktop, it will time out and shut down the screen. No, they'll never know you're on there, and nothing's ever logged because you never log onto the machine. That's one of the things we notice. It's like, hey, typically you have a log on. It shows the person logging on within the logs. You've never logged on. There's nothing in the logs. Now, if you turn on logging with enough intensity, you'd probably catch maybe applications starting and stopping if you have that capability. But it's going to be starting and stopping by system. The impersonation we have not written to work with remote desktop. There's some different issues with a remote desktop console versus a standard console. This code could easily be rewritten. The impersonation can. I think if we define in the create process as user the function to create a console, because by that we're just accepting the default console, but remote desktop, if you set the create process as user and set the console to open up, a new console to be created, you'd probably get it to work. So how do you prevent backdoors by, an example, employees? I mean, you start out with policies. Obviously, you want to set policies within your environment to protect yourself. Separation of duties. And when I say separation of duties, you think about this. If you had an employee who wanted to backdoor every machine in the corporation, how would he do it? I don't know. Where do you store your base images at? What if it happens to be the guy that does the base images? Do you have any checks and balances there? I mean, some organizations, they have one guy. He builds the base images. No one ever else looks at them. He builds them and they deploy them. So what if he built them and deployed osk.exe hack in there? What if he deployed some other kind of backdoor? These are things you need to talk about. Separation of duties is checks and balances. This person decides this is what we're going to do for a base image. This person verifies it. You have some kind of testing done to this thing prior to being deployed. And you also store those in a secure place. If you store a standard base image on the network somewhere where everyone can get access to, who's going to stop someone from replacing that with some kind of rooted code base image? Application system verification testing before deployment, obviously in reference to separation duties and the base images that you deploy in your organization. How do you prevent non-employees access? Let's think about this. Who is the maintenance man? And what do you really know about the night janitor? I mean, every place has to be clean. Do you ever see them cleaning during the day? No, they do it in the middle of the night when there's no one there. They have access to every room except for maybe your data center. So technically, they can own your network and you'll never know it and you can't stop them. Someone can use social engineering to gain physical access. Security awareness training. Keep people from just waltzing into your building. You walk to the door, you got a big box, guy opens the door for you, you walk through. It's easy to get into most organizations. So how do you protect against things? Contractual agreements with contractors and outsourcers, whether it's janitorial or application development. We're really quick for building into our contractual agreements protections for the organization for developers. Do we do that for janitors? Do we do background investigations for janitors? It's just a janitor, but the problem is we treat them just as janitors. And the fact is, we give these people access to everything on our company network if they want it. We don't do anything to stop them. ISO 17799 defines contractual agreements, and they actually mention janitorial service in those contractual agreements as part of the security part of that. So you need to consider those. So then we come to I use that bad word, defense in depth. We come into layered defense principles, the only effective method to defend your network. If you try to defend your network based on, hey, I seen this hack at this conference, so we need to do this one specific thing, you're always going to be chasing your tail. Because there's always hacks, vulnerabilities that you're never going to know about. So how do you defend yourself? And that's where you get into layered defense and defense in depth principles. It's basically a combination of people, processes, and technology applied at each layer. If one layer is compromised, your entire organization is not compromised. This is made up of policies, physical, parameter, internal network, host, application, and data layers. So let's take this instance of Bob and apply it to this right here. Okay, Bob came in. Bob gained physical access and policies. You can kind of bring those in together. If we had done a background investigation on Bob, you think we may have been found out that he was already employed or had been employed by one of our competitors doing a certain job, and now he's doing a janitor? That would put out some red flags. So if we had done that, our layered defense would have caught him at that level probably, and we would have stopped this at that layer. Okay, suppose we didn't do that and he gained access. He is a janitor. It's kind of hard to control physical access, except for maybe the data center. So we get all the way down. Okay, let's get down to the host level. If we had on the boxes set it up so that somebody walking up the box could not boot from a floppy, USB, or CD-ROM, instantly we would have stopped Bob there. That's another layer we could have caught him at and stopped him. So then we get down to the data layer. This is a research and development firm. All of their key technical stuff is probably stored on the network somewhere. If Bob could get to that data by getting into this thing, impersonating John, grabbing his security token, getting his network resources, and downloading all that stuff, we failed there because we could have prevented that. If this is the corporate secrets, why don't we have two-factor authentication set up on that? Not just encryption, but two-factor authentication. Those research and development people, that's the core of that corporation. You should protect that. That is the jewels of that organization. And the way you do it is you classify that data as a secret data, corporate secret. Require encryption and two-factor authentication. Bob may have been able to get to the data. It would have been he would have never got to the data because he would require two-factor authentication, and the data would have been encrypted. So you could have caught him there. So basically, unknowing most of the threats that may exist coming at you, if you look at these 7 layers here and apply simple security methodologies around those layers, you could stop these type of attacks from internal and external. Specifically this one, you could have stopped him at policy, the physical layer, the data layer. Any questions? Silence in the room. Yeah.
One way to mitigate that would be to require all users just to totally log off instead of locking their workstations.
Yeah, that would be a good one, but how do you force it? Yeah, that's the thing. You can have policy like that, but you have to have the ability. That's the one thing on the one slide, and it's always a killer in any organization. You can come up with all kinds of cool policies. Well, we won't let them do this. We won't let them do that. But then it's, well, how do you enforce it? You know, if John refuses to do that every day, are you willing to fire him? If you are, then that's a good policy. You can put it in there because he'll do it or he'll get fired. But yeah, that's one way. There's all these simple ways to mitigate the risk. When I first put this whole presentation